Hello everyone, and welcome to our vending machine. So today, what we have is a vending machine that will take nickels, dimes, and quarters. Our PS, so those are represented by our ND and Q, and our product select is our PS. Our price is what we're going to set the price at for the item to be dispensed. And then our coin return will be to return any coins that we have currently within the register. So first, what we're going to do is just kind of show you guys a simple little demonstration of how this circuit works. So first, right now, we have the price set to 8, which, as we know in binary, is just 1000. So how do we get to 8? Well, the easiest way for me to understand this machine is to see, we'll first start off by 8. So what is 8? Okay. 8 so since we're going by 5-cent intervals, because our lowest is nickels, it'll be 40 cents. So how do we put 40 cents into the machine? Well, there's a multitude of ways to put 40 cents into the machine, but what we're going to do today is we're going to put in a quarter first. Oops. Put in a quarter first, then a dime to bring us to 35, and then 1 nickel. So as you can see here, within our register, we have 100 or 8. So when we click the product select button, when we select the product that we would like, our LED is representative of our item being dispensed. And now our register is back to 0 with $0 in our bank, with the mux feedback of 8 still looping into the adder. Now, to represent what I meant of this coin return, so basically I could go ahead and put in however much money I would like, right? So I put in 7 or 35 cents. But I changed my mind. I don't want it anymore. So I just go ahead and click this coin return, and everything is now reset back to 0. Now to go over some kind of different scenarios within this circuit, I'm going to first start off by talking about this phrase that we learned in our unit videos when creating the circuit. And that is asking ourselves the question, what tools are in my toolbox? Now, how that phrase kind of helped me during this process of making this vending machine was taking and realizing what we've made over this course. What's in our toolbox is everything that we have readily available to us. And that can be our adder, our subtractor, registers, our comparator, our muxes. All of these we have built before within Logisim, kind of storing them in our toolbox, making wrappers that we'll be able to use later in future circuits like we have here. And I think that's very important, and I'm very grateful that we have done it and that we've done the course this way, because I think it is a great help for creating these sort of more broad circuits and a lot deeper and more meaningful circuits when we are able to have these tools that are already available to us. So going back and looking at our finite state diagram, there are 5 key components to it, and those are, we have our inputs, which are representative of our normal inputs. We have our next state logic, and our next state logic is kind of what happens inside the circuit. We have our adder, our buffers, or sorry, our propagation delay, gates, or our one shot. Our clock input, which is, this is the one shot is representative of our clock input, but I'll get more into that in a second. Our state memory, which is the middle, it's the heart of the entirety of the circuit. It's what stores the data that we need, and that is representative right here, smack dab in the middle with our state memory. And then our output logic, and our output logic is representative of this bank. And finally, our LED light, which goes ahead and dispenses our product. As you look here on this little diagram, we actually have a circuit that kind of goes back in to the next state logic, which is exactly representative of this data bus coming from the mux right here. straight back into the next state logic, which is, like I stated, our adders and such. The maximum money that we're able to accept in this circuit is 75 cents. That is the safest value that we can put everything at. Since our binary count can only go up to 15, it is the highest number that we can put it at. 15, if we're going in 5-cent intervals, the way I do it in my head is 15 times 5 is 75. So that is the highest number that we can go, or the highest cent wise we can go, but the highest binary wise we can go is 15 or F, or in binary 1 1 1 1. So if we go ahead and put 65 cents into the machine, which I will go ahead and show now. So if we go ahead and just do a quarter, a dime, and then a nickel. 65 cents into the machine. And if we go ahead and put in an extra quarter, what happens to our register? Okay, or in other words, what happens to our binary count here, right? It overfills. So now the binary counter has reset back to 2, or what we know it as 10 cents. So why does that happen? Well, simply because the binary count cannot keep adding after 111, or F is in the register. So now it resets back to that 2 value, or 10 cents. Now let's say Susie is using the vending machine and she puts in the price select, I guess, or the price that we're going to set it at is 60 cents. So how do we find 60 cents? Well, if we're going by 5-cent intervals, you do 60 divided by 5, which is 12. So we're going to set our price to hexadecimal 12, which is value C. And let's say she put in 2 quarters and 1 nickel. So we have 2 quarters. Oops, sorry. Let me go ahead and coin return this real quick. So we got 2 quarters and 1 nickel. So she still needs to put 5 more cents in, okay? So let's say she put in a quarter. Well, there's going to be some problems with that, right? When we enter in this quarter, our register is now reset back to 0, and Susie's 10 extra cents were eaten by the machine. Poor Susie. So the highest price for the machine that she should be able to put in is 75 cents. So with having that kind of projected onto the vending machine, it would help people from stopping from doing stuff like this, so their money does not get eaten. Fortunately, there's not any other really workaround behind it, but that's about as far as that goes. If pennies were introduced into this design, so as you can see, right, we have nickels, dimes, and quarters, but we're missing pennies. And if pennies were introduced into the design, I think it would change a lot of different aspects. Simply because our intervals would not be going up by 5 cents anymore, they'd be going up by 1 cent, which in turn would kind of cause internally a lot of confliction and a lot longer of a design process. And primarily what I mean by that is, if not, and let's say for example, our select was at 40 cents, we wouldn't have to remember 40 different state codes. We would just have to remember, or now we just have to remember the 8, let's say. And so adding pennies to that just adds an entire lengthier design process that will in turn create more state codes and just overall more gates and more inputs and everything of that sort. So if a vending machine manager got a vending machine in and there was wrong numbers stored inside the register, what we should do is make sure that the instructions that we give them are to automatically press our coin return as soon as they plug in the machine, right? The coin machine, the coin return completely eliminates everything that is stored in the register at that given time, completely resetting the machine. If not, if you're not giving those instructions, products will start to become undersold. Since there's already money technically or quote in the machine at all times, products will become undersold, which will lead to infinitely many or however many times that machine is used for those products to be sold, unless someone hits that coin return button. Now to kind of show you guys finally another little example, I'm going to disconnect this one hot here, or in other words, our clock. And instead, I'm going to just hook up a normal clock design to it. And now we'll begin to see that there is a little bit of, like, there's some problems that can definitely arise from doing this. So if we go ahead and turn on our auto tick, right? As you can see, if we left in certain things, it would work like normal. Um, but some problems could arise like this. Okay, so what this means now, right, is that we have a positive edge clock cycle. And the reason that this becomes a problem is because during on the positive clock edge, if you were to enter in different types of inputs, they wouldn't register. So if we do it on the negative clock edge right before it hits positive, it'll register. But if we do it off and on super fast, the inputs will not register. So if anyone were to enter in a nickel or a dime or a quarter at a positive clock edge, your money would be eaten or ate at their current time, leading to many problems. So having a clock on the actual input itself is not necessarily the greatest in design aspect. But if we go back to what we originally had, you'll see the purpose of this delay device and why we use it. So if we go ahead and get rid of this, what this delay device does is actually keeps it replaces the one hot, right? So it keeps these datas, it gives it a long enough propagation delay to keep everything inside at one time before it's passed on into the register. It gives it the cycle enough time to take in the inputs. And the OR gate helps decide which inputs are being selected into it at the time, gives it enough time to have propagation delay in, and then finally feeds into the register. And the reason we call this a vending machine controller is because we're able to control which inputs go in and out of the system and how much money we are able to have left over. And speaking of leftover, I never showcased a example where we will still have money inside the bank, which is a possibility, right? If the set price for this is 40 cents and we entered in 50 cents and we go ahead and click our select button, our vending machine will be dispensed, but we will still have 10 cents left over, which is represented by this 2 here, or binary 1010. There are definitely other sorts of components that go into a whole bunch of different vending machines. One of them, which we've previously stated, which is pennies. You know, we don't have penny inputs in here, so that overall change the design process. And there's multiple reading cards, um, different types of coin returns, entering dollar bills instead of pennies. Um, it basically just adds layers to this vending machine. And different types of engineers can work on those. Any type of engineer, whether it's a software engineer who writes the different codes for the type of vending machines, or it goes back to the gate and logic level and creating just deeper and larger circuits that will accept the dollar bills and the pennies and other stuff like that. And that's all I have for you guys today. Thank you.